Good morning, students. Now we start unit number 5 of Theory of Machine. Here is the first topic is brake. Brake is a device used to stop or retard the motion of a body by applying artificial frictional force or resistance with the help of bell crank lever or brake pedal. The requirement of good braking system is to stop the vehicle within the shortest distance and shortest time. The good braking system has less bearing parts and parts having long life. Third is good braking system develops minimum sound when we apply the brakes. The next is good braking system has work within less effort. That means when we apply a minimum load, it should work. Next is braking system has low maintenance cost. And last one is braking system should work on all weather conditions. Here is most important part of braking system is liner. Liner are attached to inner side of the brake. The requirement of good lining material in braking system. First one is liner has low wear rates. Second is liner has high heat resistance capacity. Third is liner has high dissipation capacity. Fourth is liner has good mechanical strength. Next is liner should not affect by moisture and oil. And last one is liner has high coefficient of friction. Now here is classification of braking system. First main classification is block and shoe brake. This is also classified in three types. First is single block brake. Second is tapered block brake. Third is double block brake. The second main type of classification is band brake. This is also classified in two types, simple band brake and second is differential band brake. Third main type classification is band or block brake. Fourth main type classification is internal expending brake. Now we discuss here single block shoe brake. In figure, there is a rotating wheel. This is bell crank lever. This is block or shoe brake. This is fulcrum where bell crank lever rotates. Now here some terminology is used for determining the frictional torque or frictional force. P, force applied at lever end. Rn, normal reaction on block. Mu, coefficient of friction. Small r, radius of wheel or drum. 2 theta here, angle of surface contact. Now we see in figure, this is 2 theta. This angle is 2 theta. Next is Fr, fractional force that is equal to mu Rn. Next is FT, tangential braking force. Here is some terminologies. TB, please mention. TB is braking torque applied on wheel. Now here case 1. The line of action of braking force passes through fulcrum of lever point O. This is point O. Here is noted the line of action of braking force passes through the fulcrum at point O. Please see in figure. The line of action of frictional force is this. The line of friction is passes. Line of action of frictional force is passes through the point O. This. Please note it down. Here P is the applied force in downward vertical direction. R and normal reaction in upward direction. Please change figure. This is Rn. This is the point O. X is the horizontal distance of point O to force Rn. Small l is the horizontal distance from point O to applied force. In case 1, the wheel is rotated in clockwise direction. So, frictional force or tangential force is rightward direction. That means direction of motion of wheel. And friction force is applied in opposite of tangential force Ft. That is equal to Ft is equal to mu Rn. That means the value of Ft is equal in magnitude of value of mu Rn, but opposite in direction. Now case 1 sub case wheel rotate clockwise direction, taking moment about point O, P into L, perpendicular force into perpendicular length. P into L is the couple in clockwise direction about point O minus Rn normal reaction into perpendicular distance x. This is in anti-clockwise direction about point O. There is no other forces or couples in perpendicular direction or making a couple about point O. That means P into L minus R into X equal to 0. This is simplified as P into L equal to Rn into X. Here Rn Normal reaction equal to P into L upon X. Now, tangential braking force Ft. This is also in direction of motion of wheel. So, tangential braking force Ft, this is equal to mu Rn. Now putting the value of mu Rn from here to here. So, we can obtain the value of tangential braking force Ft is equal to mu P L upon X. This is tangential braking force. Now we can calculate tangential braking torque TB. This is TB is tangential braking force into radius of wheel. Please see in a figure. Tangential braking force Ft into R, radius of wheel. This is the R, radius of wheel R. So TV is equal to F into R. Now put the value of Ft, tangential braking force, from here to here. Now we can obtain tangential braking force. Tangential braking force mu P L small r upon X. Now here the mention direction clockwise. Please see in a figure. Ft is in right direction and R is this. So you can see this is the couple in clockwise direction about center of wheel. Okay. Now second condition, when wheel rotates in anti-clockwise direction, anti-clockwise, please mention here clockwise to anti-clockwise. Please see in a figure as is similar as previous one. Wheel rotates anti-clockwise direction. Here is P, applied force. Here is fulcrum point O, and tangential force, line of action of tangential force, this one is passes to the fulcrum point O, this one. Now this is the mu, this is the Rn, normal reaction in perpendicular direction, is the X, oriental length from fulcrum to normal reaction direction, and small l from point O to applied force. Now the main important thing is this is the direction of rotation of wheel. So the direction of rotation of wheel is anti-clockwise direction. So tangential force is in this direction and frictional force opposite in tangential force direction, that is in rightward, and the value is mu Rn. Here is noted down. Ft is equal to mu Rn. In previous case, the wheel is rotates in clockwise direction and tangential force is on towards right side and frictional force is in left side, that is equal to mu Rn. Now in this case, taking moment about point O, here is the vertical force P into perpendicular length P into L is in clockwise direction about point O, and minus Rn into x. Rn normal reaction into perpendicular direction into x. This is in anti-clockwise direction about point O. So P into L in clockwise direction, that assume positive sense, and Rn into x in anti-clockwise direction about point O, that assume in negative sense, that is equal to 0. Now we can simplify as P into L equal to Rn into x. Here we can obtain Rn normal reaction values as P into L upon x. Now tangential braking force is equal to Ft equal to mu Rn. The value of Rn here, the value of Rn is put it down in value of tangential braking force. Now we obtain value of tangential braking force as mu into P into L upon x. Now here tangential braking torque Tb. Tb is tangential braking force into radius of wheel. Tangential braking force upon radius of wheel R. Tv is Ft into R. The value of Ft from here is put it down in equation here. So Tv tangential braking force torque is mu into P into L into R upon X. Now here direction is anti-clockwise direction. That is very important. Please see in a figure, Ft is left side force and R is here, and this is the center of wheel and this is the wheel, and Ft. Tangential braking torque is in anti-clockwise. That means Ft it rotate about point center of wheel. This is in this direction. So here the direction of tangential braking torque is in anti-clockwise direction. Now case 2. When line of action of tangential braking force at a distance a below the fulcrum point O. Please see in a figure. The line of action of tangential braking force is below at a distance A from fulcrum point O, and condition number first is when wheel rotate in clockwise direction. Wheel rotate in clockwise direction. So let's see in figure. Wheel rotates in clockwise direction. So Ft is towards right side, that we also discussed. P is downward vertical force. Mu Rn is the normal reaction. O is the fulcrum of bell crank lever. X is the horizontal distance from O to Rn. L is the horizontal distance from point O to applied force P. Now, taking moment about point O here, P into L, P into L. P applied force into perpendicular distance about point L. That means P into perpendicular length P into L. It makes a clockwise couple about point O. So we assume here clockwise couple is positive sense and anti-clockwise couple at negative sense. So here P into L is clockwise direction couple, so P into L is positive sense. And next is minus R into X. Rn is normal reaction and its perpendicular length for motion about point O is small x. So Rn into X in negative dash sense because Rn is perpendicular force in upward direction and its motion about point O as clockwise anti-clockwise direction. So R into X in negative sense. And third couple is tangential force Ft. Ft is applied towards right side and its perpendicular distance about the rotation is A. So couple value is Ft into A. This makes a anti-clockwise couple about point O. So Ft into A also negative sense. So the equation makes P into L minus Rn into X minus Ft into A equal to 0. Here we also known as Ft is equal to mu R n. This is always remember in braking system. This equation is simplified as PL equal to Rn into X plus Ft into A. Now putting the value of Ft in this equation, so we can obtain PL into X, PL equal to Rn into X mu Rn into A. as simplified to equation this. From equation this, Rn is common in right hand side, so we can obtain equation PL equal to Rn is the common and x plus mu. So we can obtain value of Rn normal reaction PL upon whole of x plus mu a. Now tangential braking force Ft is equal to mu Rn. Here the value of Rn is put it down in tangential braking force equation. So we can obtain tangential braking force as mu P L upon whole of mu A plus x. Again I repeat, tangential braking force Ft equal to mu into P into L upon x plus mu A. Now tangential braking torque Tb. Here Tb is equal to Ft into R. We can see in previous case tangential braking torque is tangential braking force into radius of wheel. So here Tv is Ft into R. Now the value of Tv is put it down in tangential braking torque equation. So we can obtain by tangential braking torque as mu into P into L into small r upon x plus mu a, and the direction is clockwise direction. Please see in a figure. Ft is this and R is this. This is the center of wheel. So it makes a clockwise couple of Tb. Tb is tangential braking torque. This is case number second. Now moves on case number second, condition number 2. When wheel rotates anti-clockwise direction. Anti-clockwise direction. Now see in figure. This is similar to previous one. This is direction of motion of wheel in anti-clockwise direction. The tangential force is applied on towards left side. This is the A, because line of action of tangential force is below at a distance A from fulcrum point O. This is the A, and here applied vertical force are in normal reaction, small x, small l. This is simply as previous one. Now in taking moment about point O, here P into L applied force into perpendicular distance L, it makes a clockwise couple about point O. So clockwise couple is assumed positive sense and anti-clockwise couple sense negative sense. Here P into L is makes clockwise couple, value of PL is positive. Second one, Rn is a vertical upward force and makes a couple at anti-clockwise sense about point O. So Rn into x is negative. And next couple is Ft. Ft is in left side direction and vertical distance it's A. It makes a clockwise couple about point O. So we assumed clockwise couple in positive sense. So equation generates P into L minus R into X plus Ft into A equal to 0. This is the equation of sum of force equal to 0. P also known as Ft is equal to mu Rn. So the equation simplified and putting the value of Ft in this equation. Simplify equation this P into L equal to Rn into X minus Ft into A. Putting the value of Ft in this equation. So simplify equation is PL equal to Rn into X minus mu Rn into A. Rn takes common from right hand side and simplified equation is PL into PL equal to Rn and X minus mu A. Please see here. PL equal to Rn X minus mu A. From this equation, we can calculate value of Rn normal reaction is equal to P into L upon X minus mu A. In previous case, when wheel rotates in clockwise direction, the value of Rn is differ from here. The value of Rn when wheel rotates in clockwise direction is PL upon X plus mu A. Now, tensile braking force Ft is equal to mu Rn. The value of mu Rn, this value is put it down in tensile braking force equation. So we can obtain the value of tensile braking force Ft, that is equal to mu P L upon X minus mu A. This is Ft is equal to mu P L upon X minus mu A. Now we also calculate tensile braking torque Tb. Tb is Ft into R. We also known as Tb tensile braking torque, tensile braking force upon perpendicular length or radius of wheel. So the value of Ft is put in tensile braking torque equation. So we can obtain tensile braking torque as mu P L R upon X minus mu A. Here direction is anti-clockwise direction. The direction of tensile braking torque is anti-clockwise direction. Please see in a figure. Here the Ft is left side direction and this is the R and this is the radius or center of wheel. So Ft makes a anti-clockwise direction couple or torque about center of wheel. So today we are stop here, and in next lecture we discuss case number 3. Thank you.